In the previous video, we went over part 1 of this question to detect sequence 00111. We made the state diagram as shown here, and we built the state transition table. In today's tutorial, we're going to go over part 2. We're going to design the circuit using D flip-flops. So as we saw in the D flip-flops, that the D flip-flop symbol has two inputs, D and the clock, and it has two outputs, Q and Q bar or Q prime. And we also saw that Q plus is equal to D. So as we saw in the first part that we need 3 D flip-flops to design this circuit. So let's continue our table here. So we're gonna need, let's call them the inputs, let's call them D3, D2, and D1 to stay consistent. So D3 is the input for one of the D flip-flops, D2 is another input, and D3 is another input. So in D3, this one will be equal to this state, Q3 plus, and D2 will be the same as Q2 plus, and D3, this should supposed to be D1, and D1 is equal to Q1 plus. So simply we're gonna rewrite these here in this location. So let's do this. So next we're gonna use K-map to get the Boolean expression of D3, D2, and D1 as a function of Q3, Q2, Q1, and X. So first let's start with D3. So since we're gonna get it as a function of Q3, Q2, Q1, and X, we need 4 variables K-map. So on this side, let's list Q3, Q2, and then on this side, let's list Q1 and input X. And this will have 4 columns and 4 rows. On this side, as we saw on the K-map, we're gonna have 0, 0, 0, 1, 1, 1, and 1, 0. And then for Q1X, same thing, 0, 0, 0, 1, 1, 1, and 1, 0. So now we're gonna look at D3 at the location where it's 1. So it is 1 at this location, 0, 1, 1, 1. So now we're gonna go look in here. So 0, 1, this is 0, 1, and this is 1, 1. So we're gonna have 1 in this location here. And also we don't want to forget about the unused states. So we mentioned we're using 5 states, S0 through S4, and S5, S6, S7 are unused. So each one of these, 1, 0, 1, we could enter an input of 0 or 1 next to it. So let's rewrite them down here. So we're gonna have the unused states. So we're gonna have 1, 0, 1, we're gonna write it twice with 0 as an input and then with 1 as an input. So this is for S5. Similarly for S6, 1, 1, 0, we're gonna write it with input 0 and 1, 1, 0 with input 1. This is the S6. And then S7, 1, 1, 1, we'll write it twice with input 0 and input 1. Now these states and the K-map are treated as we don't care about the value. It could be 0 and it could be 1. So let's have where we have 1, 0, 1, 0. So first we have 1, 0 in this row, and then we have 1, 0 here. So this is don't care term. We have 1, 0, 1, 1. This is don't care term. We have 1, 1, 0, 0, 1, 1, 0, 0 in this location, don't care. Next, we have 1, 1, 0, 1. 1, 1, 0, 1 is in this location, don't care. Last one, we have 1, 1, 1, 0. So this is 1, 1, 1, 0. This is don't care. And then lastly, 1, 1, 1, 1 in this location. Now the rest will be zeros. So this is very important to know where we have don't care because this will give us the absolute minimal Boolean expression form. So now we can group this one with this don't care term and treat this don't care term as 1. So this will give us from here to here, Q2 is not changing and it's 1. So this will be Q2. And then in this area here, we're gonna get Q1X because they're both 1s. So now we can write D3, let's write it here. D3 is equal to Q2, Q1X. So let's do for D2. The don't care term will be the same. So let's fill them. Now let's look where D2 is 1. It's 1 in this location. This corresponds to 0, 0, 1, 0. 0, 0, 1, 0 is in this location. Next time we have 1 is in this location here. So this corresponds to 0, 1, 0, 0. 0, 1, 0, 0 is in this location. We're going to have 1. Next time for D2 where we have 1, it's in this location here. And this corresponds to 0, 1, 0, 1. So that's 0, 1, 0, 1 is in this location. Now the rest are zeros. So now let's do the grouping. We want to do the grouping in the largest group of 1s that we could. So these 2 1s, we can group them with these 2 don't care term and treat those 2 don't care terms as 1. So this is a group of 4. And now this one, How can we group it? We can group it with this don't care term and treat it as 1. We don't have any other ones, so this is it. So for this group, we're gonna get from here to here, Q2 is not changing and it's 0. So this will be Q2 bar or Q2 prime. And then in this area, we have Q1 is 1 and X is 0. So this will be Q1 X prime. Now for the group in green, so from here to here, Q2 is not changing and it's 1. So this will be Q2. And then from here to here, Q1 is not changing and it's 0. So this will be Q1 prime. Now we can write the Boolean expression for D2. D2 will be equal to the summation of those two terms. In red, we have Q2 prime. So next, let's do D1. So for D1, let's start with the don't care terms first. We have in the same location. Next, for D1, let's look in the location where it's 1. We have 1 here, 1 here, 1 in this location, and 1 in this location. So now we know where to fill ones. For 0, 0, 0, 0, we have 1. Now the rest will be zeros. So now we can do the grouping. So let's see how we can group the ones together. So for this one, we can group it with this don't care term and treat it as 1. So this is one group. This one here, we can group it with this don't care term and treat it as 1. And this one can be grouped with this one here at the bottom. And this is it. So now we can write the expression. So from this group here, we're going to get from here to here, Q2 is not changing, it's 0. So this is Q2 prime. And then we have Q1 prime, X prime. For this group here, we're going to have from here to here, we have Q2 is 1. And then in this area here, we have Q1 X prime. Lastly, this group here, we have a Q2. And then in this area, we have a Q1 prime X. So now we can write the Boolean expression for D1. We're going to need one more Boolean expression for the output. This is the output. It's 1 in this location. This corresponds to this group here. So let's write the Boolean expression for the output Z is equal to Q3 is 1. So this will be Q3. Q2 is 0 and Q1 is 0. So this will be Q2 prime, Q1 prime. And X is 1. So this will be X. So now we can take this 4 Boolean expressions and draw the circuit. So let's do that. So we need 3 D flip-flops. Let's draw them here. So D flip-flop has 2 inputs. D, let's call this one D3, and a clock. And then it has a Q3 output. And we can also have Q3 prime. Okay, so now we have the 3D flip-flops. Each one has D input, data input, and the output Q3 and Q3 bar, and so on. So let's start with D3 Boolean expression. So it is Q2, Q1, and X. So we need an AND gate, and then it has 3 inputs. So let's draw the inputs, 1, 2, and 3. So we need a Q2, Q1, and X. So Q2, we can take it from here. So this is Q2, Q1, and X input. We know where to get Q1. Q1, we can take it from here. So this is it for D3. Now let's do D2. Let's do this Boolean expression. So we need an OR gate because we have summation, and 2 AND gates because we have 2 terms. So first we need an OR gate, and then we need 2 AND gates. The first AND gate has 3 inputs, and then the second one has 2 inputs. On this one, we need Q2 prime, Q1, and X prime. So this is a Q2 prime, Q1. And to get an X prime, we need a NOT gate here. And we can branch it from this X. For this AND gate, we need a Q2, Q1 prime. So this is a Q2, Q1 prime. And then lastly, for this Boolean expression for D1, so we need an OR gate, and then we need 3 AND gates. And all of them will feed into this OR gate. For the first one, we need 3 inputs. So this is 1, 2, and third input. For the second one, we need 3 inputs for each one. For this AND gate, we need a Q2 prime, Q1 prime, and X prime. For this one here, we need a Q2, Q1 prime, and X. And then for this one, lastly, we need Q2, Q1, and X prime. So this is Q2, Q1, and X prime. So that's it. We know where to get X if we need it. We know where to get Q2 prime, Q1, and so forth. We can get them on this side. So lastly, let's do the output. So Z, we need an AND gate. The output, we call it Z. And then this AND gate takes 4 inputs. So this is 1. So we need a Q3. We can take a Q3 from here. We need a Q2 prime. We have Q2, we have Q2 prime. We can take it from here. Or we can put a NOT gate and take it from the Q. Q2. This will be Q2 prime. Also, we need a Q1 prime. And then lastly, we need user input X. Also, we can branch it from here and feed it all the way to this input. So this is it. This way we completed the circuit using 3D flip-flops. This is one, second one, and third one. So the clock, we are gonna need to connect them all to a common clock input. So we can do this. And this will be our common clock inputs. So the circuit technically will have a clock input and then user input X. And then on the output, we're gonna have the output Z. Of course, this clock will be connected to this clock, and then the user input X will be connected here. And then when we detect when the user enters 0, 0, 1, 1, 1, so the output should be 1. Otherwise, it should be 0. I hope this was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.